Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic, a simple C program with basic data and operation. The program in the last example was to illustrate how a basic C program will look like. This program did not have the data. Let's consider one more example, program which performs operation on data. Let's declare and define a function called add, which accepts two integers, adds them up, and returns their sum as output. This is the declaration of the function add. It has two parameters, both are integers, and its return type is an integer. The main function has declaration statement in which three integers have been defined, int num1, num2, and variable sum. The main function prompts the user to enter first and second number, and using these inputs, it invokes the function add. The function add receives the two numbers as arguments and returns their sum, which is assigned to the variable sum inside the function main. Finally, the function main prints the sum and returns. Here, the function main did not care about how to perform the add operation. It just called the function add, which took care of this task. This is the definition of function add. The header specifies the return type and parameters. The body of the function has one statement, a return statement, which is returning the sum of A and B. Preprocessor directive. This is used to include the standard input-output header file, which contains declarations for input and output functions, such as printf and scanf. Now let's see the output of the program. Enter first number. Say you enter 10. Enter second number. Say you enter 20. The output is the sum of 10 and 20 is 30. Now let's see some technical terms and their explanations. Variable declaration declares variables and specifies their data types. Input-output statements statements that interact with the user to get input or display output. Assignment statement assigns a value to a variable. Example, sum assign add of num1, num2. Format specifier used in IO functions to specify the type of the data that's being read or written. Example, %d in scanf. Address of operator obtains the memory address of a variable, such as ampersand used along with num1 in ampersand num1, which is in turn used in the scanf function. Arithmetic operator performs arithmetic operation on variables and values, like plus in return statement, return A plus B. This is the basic layout of a computer system. A computer system has an input device, an output device, a secondary storage like hard disk, CPU and RAM. CPU and RAM are electronic chips present on the motherboard inside the cabinet. The data files, source files, and exe files, etc. are stored in the disk in some path inside a folder. RAM stores the data and instruction of the program, and CPU performs operation on the data in the RAM based on the instructions present in the RAM. Program receives data from an input device such as keyboard and displays data on an output device such as monitor. Now, in our first example, we created a source file, then we compiled that source file to generate an exe file called hello. Then we run the program hello, right? where is this source file hello.c and the exe file hello, which was generated by compiling hello.c present? It is present in the disk somewhere, in some folder, right? Now let's try to understand what happens when you execute this command /hello. The user interface of the operating system, the shell in case of Linux, will load this exe file into the RAM. And then the CPU runs this program by fetching one instruction at a time from the RAM. And if there is data present in the program, it starts fetching that data and perform operations as per the instructions of this program on the data. So this is how a C program executes inside a machine. When we create a variable of basic type, the compiler ensures that the memory is allocated to the variable inside the program. Every memory location that is allocated to a variable has an address and a container where the data is stored. Let's consider one example program. In this program, variables a, b, and t have been declared as integer. When we create a variable using declaration statement, int a, for instance, a is allocated a memory location at the time of compilation. In this case, the memory location allocated to a has the address 1001x, and we have stored 50 in this memory location. Whenever you access here, you will actually be accessing the value in that location, that is 50. And whenever you access ampersand a, you are actually accessing the address 1001x. X here indicates the number is in hexadecimal. Similarly, whenever you access b, you are accessing 70, and whenever you access ampersand b, you are accessing the address 1050, etc. So you can either access the contents by using the variable name, or you can access the address by using the ampersand followed by the variable name. So with this knowledge in mind, let's try to write a simple C program to exchange the values of two variables. So here is a simple program. The program receives values for A and B using the scanf statement. In scanf, to receive a value for A, you have given the address of A. Scanf should know 1001x location. Then it can store the value there, and it should know the address of B, that is 1050, to store the value there. Right. So you have to specify the address and the type of the input you are receiving to the scanf function. %d implies we want to receive an integer, and ampersand a or ampersand b implies that this is the exact address. The scanf will receive one integer for a and one integer for b and store that value in the corresponding memory location. 50 and 70 are the values assigned to a and b. Let's try to exchange the values by storing 70 in a and 50 in b. Our objective is to exchange the values present in a and b. When I print a and b, it should be printing 70 and 50 rather than 50 and 70. But our current state is that a holds 50 and b holds 70. We want to exchange them. How we can achieve that? Consider a scenario where you want to exchange the contents of two glasses. Say in one glass there is milk, and in another glass there is water. You have a glass of milk, you have a glass of water. If you are asked to put water in milk's glass and milk in water's glass, how do you do that? You stop this video, think for a while how it is achievable, then continue watching this video. Simple. Did you think? Take another glass, put milk in that glass. Now the milk glass is empty. Now put the water in the milk glass. Now water glass is empty. Now put the milk from the third glass to the water glass. Right. So we are able to exchange the contents of two glasses by using a third glass. Similar is the concept used to exchange the values of two memory locations. Hope you have understood the concept here. The glasses were containers. Same way, these memory locations are containers with addresses. A and B represent the value in the container, and ampersand A and ampersand B represent their addresses. Now, in order to exchange, what we can do, we should directly write B to A. What happens? 70 overwrites 50, and both places you will have 70. That is not what we want. 50 is lost, right? So you do not want 50 to get lost. So let's store the value of A into T. This is the assignment statement. It means you are assigning the value A to T. So T will store 50. Next, A assigned B means 70 is moved to the memory location of A. So 50 is overwritten. So at both places we have 70. Now who holds 50? The variable T holds 50. So that 50 is assigned back to B. This way we can exchange the values of A and B. And when you finally print A and B, you see their values as 70 and 50. So we have been able to exchange the values of two variables using a third variable. The output of this program is enter values for AB. Say user enters 50 and 70. The values of AB after exchange 70, 50. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.